Hi, this is question 6 from the AQA Further Pure January 2013 exam paper. In this question we're told that a plane has equation r dot 12, 15, 16 is equal to 11 and the point Q has coordinates 1, 1, negative 1. For part A we need to show that Q is in the plane pi. So for this part we simply need to plug 1, 1, negative 1 into this equation here. So if I do 1, 1, negative 1, and I'm going to dot that with 12, 15, 16, and I get 1 times 12 is 12, 1 times 15 is plus 15, and negative 1 times 16 is take away 16, which is equal to 11. So therefore Q is in pi. Okay, part B says write down the Cartesian equation for the line L which passes through the point Q and is perpendicular to pi. Okay, so to work out the Cartesian equations, I'm now going to, well, I know that the line L passes through Q, and if it's perpendicular to pi, then L must be in the direction 12, 15, 16, because this is the normal to the plane. So I know the direction, and I know that it passes through the point 1, 1, negative 1, so I could write R is equal to 1, 1, negative 1 plus lambda times 12, 15, 16. Okay, so to write this in Cartesian form, well, I'm going to call this x, y, z over here, and then I'm going to subtract this from both sides of my equation. So I'm going to get, I'll write it over here, we will have x take away 1, y take away 1, and z plus 1, and that's going to be equal to lambda 12, 15, 16. Okay, so I've just put in x, y, z here and subtracted this from both sides, and that's what's given us this. So what they're saying is that these are parallel to each other. So that means that x take away 1 divided by 12 must give me lambda, y take away 1 divided by 15 must give me lambda, and z plus 1 divided by 16 must give me lambda, which means that each of those three things are going to be equal to each other. So over here I'm going to write down that x take away 1 over 12 is equal to y take away 1 over 15, and that's going to be equal to z plus 1 divided by 16. Okay, so that's linking together my x, y, and z coordinates, so this is now in Cartesian form. Okay, part 2 says deduce the direction cosines of L. Well, my direction cosines of L are going to be given by the magnitude of this vector, and then each of these divided by the magnitude. So if I had, so I'll write it down over here, we'll have cos theta with the x-axis, and that's going to be equal to 12 divided by the magnitude of this vector. So I'll just work that out quickly, and that's going to be 12 squared plus 15 squared plus 16 squared, and if I square root that I get 25. Okay, so that's going to be 12 divided by 25, and what that's telling me is the cosine of the angle made with the x-axis. Okay, so that's my adjacent divided by my hypotenuse, and my hypotenuse is given by the magnitude of this over here. So I've got cos theta in the y direction, and that's going to be 15 over 25. And cos theta in the z direction is going to give me 16 over 25. Okay. So you go for that. That's another 2 marks there. Part C says the pointer M and N are on L, and each is 50 units from pi. So we need to find the coordinates of M and N. So if we just imagine here that we've got my plane, I'll just draw a diagram over here. So we've got my plane that's going to look like this here maybe, and then we've got a line that's passing through my plane, and it's going to be perpendicular to it. Okay, I apologise for my dodgy drawing here. Let's just move that over here. Okay, so that's a line passing through my plane, and we know the equation of that line is going to be we'll use the vector form of it. So this here is going to be the equation of that line. Okay, the point 1, 1, negative 1 is going to be that point there. That's 1, 1, negative 1, and this 12, 15, 16 is the direction that where we're going in. Now we know the magnitude of this because we worked it out. This is 25 units, so this has a size of 25 units. So if we said that there is 12, 15, 16, so that's 12, 15, 16, and that is actually 25 units long, because we worked that out over here when we worked out the magnitude. So if that's that point there is I'll just draw an arrow here. That point there, the position vector is 1, 1, negative 1. So if I add on this vector here, 12, 15, 16, that's going to take me 25 units away from 1, 1, negative 1. So if I add it on again, that's going to take me 50 units away from 1, 1, negative 1. Okay, so that there could be point M, which is 50 units away. This point here, well, if I subtracted this away from this point here, point Q, that's going to take me 25 units away in the opposite direction, and if I do that again, that takes me another 25 units away from Q, and that takes me 50 units away. So that point there is going to be N. So when lambda is equal to 1, I'm adding on 12, 15, 16 once, but when lambda is equal to 2, I'm going to add it on twice. And if lambda is equal to negative 2, I'm going to take it off twice. So I hope that kind of makes sense. So what I'm going to do is I'm going to let lambda equal 2, and then let lambda equal negative 2. So for point M, so we'll call that OM, and that's going to be equal to 1, 1, negative 1 plus 2 times 12, 15, 16, and that's going to be equal to 25, 31, 30, 31. Okay, so that's going to be one of my points, which could be M or N. Okay, my other point, I'll do that in green over here, O-N, well, that's going to be equal to 1, 1, negative 1, take away 2, 12, 15, 16. So that's going to be 1 take away 24, which is negative 23. And then I've got 1 take away 30, which is negative 29. And I've got negative 1 take away 32, which is negative 33. Okay, so that's going to be the point N. Okay, so my coordinates of m and n. For m, we're going to have 25, 31, 31. And for n, we're going to have negative 23, negative 29, negative 33. Okay. Right, finally, part D says, given that the point P, 5, 1, negative 4 is in pi, we want to determine the area of the triangle PMN. Okay, there's actually quite a few ways that we can do this. One way that we can do this is, we've already got a diagram there, so let's just mark on the point P. Now we know P lies on the plane, so it doesn't really matter where I mark it, so I'll mark it over here. So we'll call that point P, and point P is got the point 5, 1, negative 4. Okay, so now what we're saying here is that we've got a triangle that's made up from P to M and P to N. Okay, so we're trying to work out the area of this triangle here. Now we already know the base of this triangle is going to be 100. So what I can do with knowing is what the height of this triangle is going to be. Okay, so that's my base there of 100. What's the height of the triangle going to be? Well, I can work that out because I know that I've got the point 1, 1, negative 1 here and 5, 1, negative 4 here. So if I can find the distance between those 2 points, because they both lie on the plane, that's going to be perpendicular to the base. So that's actually going to be the height of the triangle. So I can then simply just do the base times by the height divided by 2. So let's go about working this out. So that's the point Q, and at the point P, and we're trying to find the magnitude of, we'll call it PQ. Okay, so we're trying to find the magnitude of the line PQ. Okay, so well, PQ is going to be equal to Q take away P, so that's going to be negative 4, 0, and negative 1 take away negative 4, which is going to be 3. Okay, so the magnitude of PQ is going to be 16 plus 0 plus 9 square rooted, which is actually going to be the square root of 25, which is 5. So the height of this triangle here is actually going to be 5. We know the base is 100, so we want to do the area of my triangle is going to be equal to 100 times 5 divided by 2, which is going to be 250 units squared. Okay, I hope that was useful, and I hope all of that made sense. I'm sorry it's all a little bit messy. I was just trying to squash it all in here. Thanks very much for joining me, and I'll see you next time.